Okay, balancing equations. As I said in lecture, it's a skill we continually need to practice. It's a very important skill in chemistry. And it's like any other skill in chemistry. You're only going to get better at it by doing more and more questions. So I've got this balancing equations worksheet. I've posted it for some more practice for you. I want to work through the first couple of examples with you and give you some strategies, help you think your way through how you're going to balance these equations. Now, first of all, we just want to confirm that we are dealing with equations where we've got reactants and products. And if I were to take a look at the reactant side of each of these equations, I should have a certain type of atom on the reactant side. Okay, I'm going to have more than one type of atom on the reactant side, but I should have those same atoms on the product side. All right, because we're balancing equation, so we have to have the same types of reactants. So if I just scan through this first equation, I noticed that on the reactant side, I've got some H's. I've got a PO4. Now, do I need to break that PO4 up into P's and O's? I really don't, because if you notice, the PO4 kind of stays together as a unit. So instead of writing the P's and the O's separately for this one, I'm going to write the PO4 as a single unit. I'm going to deal with it as a single unit. I also noted that I've got some K's on the reactant side, and I've got an OH. Now I'm going to write that OH as a unit, right? As a single unit. And you're probably looking on the product side and wondering where that OH goes, where that OH is on the product side. Well, we'll get to that in a bit. Let's just take a look at our product side. What are the different species we have there? Well, we've got H's. Yeah, we've got H's on the product side. We've got PO4s, yeah, we had already established that. We've got PO4s on the product side as well. We've got K's on the product side, and we've also got some O's, but we've listed them as OHs on this side. So let's just list them as OHs on this side as well. Now you're probably wondering, I don't see any OHs on the product side. If I were to rewrite water, and this is what you might want to do for a lot of questions in which water is going to be a product, you need to see where the water is coming from, where the two components are coming from that make that water. Water is the same thing as HOH. So now I can see that some of my OHs from the reactant side here are probably going to combine with some of these H's here to make water. So now I've got a better idea as to how I can balance this, where things are coming from. So let's get to the balancing part now. The first step in balancing is to recognize that, and once again, I'm just going to write this as HOH, right, for the purposes of our balancing to make it a little bit easier. Find one thing that is not balanced. And what I mean by not balanced, I have more of them on either the reactant side or on the product side. So right away, my eye kind of zooms into potassium. I've got 3 potassiums on the reactant side, but on the on the product side, but on the reactant side, I only have 1. Here's my 3 on the product side. So to make sure I have 3 on the reactant side as well, I need to put a coefficient here, because what this coefficient does is it multiplies everything behind it by 3. So it's going to give me 3 potassiums and 3 OHs as well. Now, the next thing, what else do I need to make sure is balanced? So right now, the PO4s look okay. There's one PO4 here. There's one PO4 there. If I were to take a look at the H2O, and I'm just going to replace it with HOH. It's the same thing. I've just written it differently. I notice that I have 3 OHs on my reactant side and 3 H's. Now, those 3 H's and 3 OHs will come together to form 3HOH or 3H2O. Same thing. Let's take a quick scan. It looks now like everything is balanced. We're going to do a check in a second. So let's just take a look at the table now that I just kind of sketched in here. In that table, we've got H's, PO4s, K's, and OHs on the reactant side. Let's count up how many. So quick count. Looks like I've got 3 H's on the reactant side, 1 PO4. Don't forget this coefficient means I've got 3 K's and 3 OHs. Let's take a look at the product side now. The product side. A little bit more challenging. I've got 3 H's here, 3 OH's. I've got 3 K's right here, and 1 PO4. My job is to make sure that these numbers match up. 3, 1, 3, 3. So that means that I've got the same number of each type of atom on both the reactant side and the product side of this equation. So that one's balanced. All right, see if we can do another couple before I leave you to complete the worksheet on your own. All right, so let's take a look at example number 2 now. Example number 2. Once again, our job is to try to find something that is unbalanced between the reactants and products. And right away, I notice that I've got 2 B's on the reactant side, only 1 on the product side, so I'm going to put a 2 here. Next thing, what else is unbalanced? I notice that I've got 3 oxygens on my reactant side, but only 1 here. So I need to put a 3 in front of the coefficient, 3 in front of the K2O as a coefficient, because what that's going to do is going to multiply the oxygen by 3, giving me 3 oxygens. But it also multiplies the K2 by 3. So now I've got 6 K2s on the product side, but only 1 on the reactant side. So what we'll need to do is put a 6 in front here. Now, I didn't do this for the first equation that we balanced, but I'm going to strongly recommend that if you have a blank, it doesn't mean that you have 0 of that particular species. It means you have one of that particular compound. All right. Some students think that because there's a blank there, it means that there's none of them. No, it means there's 1 of them. We don't have to put the 1, but I'm going to insist that you put 1 as a coefficient if you only have 1 of that particular compound. All right, so let's put in all the blanks so that we don't have any of these spaces without a number in front of it. Now let's do our quick count, just as we did in the first example. On the reactant side, I've got K's, I've got B's, and I've got O's. On the product side, again, K's, B's, O's. I'm listing them in exactly the same order. Let's do a count on the reactant side. 6 potassiums, 2 borons, and 1 times 3, 3 oxygens. Let's take a look at the product side. 3 times 2 is 6 potassiums, 3 oxygens, and 2 borons. There we go. The numbers match up, so I know that this one now is also balanced. All right. Let's take a look at the next. Okay, we want to do a couple of these together so that you are a little bit more confident, and then we can kind of move ahead and get you to finish up the rest of the worksheet. Okay, so let's take a look at this next one. Again, here's some OHs, here's some H's. Let's just rewrite my H2O as HOH. You're going to have to do this on some of the equations you balance because it makes it a little bit easier to see how this HOH or H2O is being formed. I've got OHs here combining with H's here. And I can't seem to find anything that is not balanced, right? Here's my H's combining with my OHs. 1H, 1 OH. So it looks like I have 1 of everything. You can take a look, pause the video, take a look. But I think everything is balanced. Let's just be sure. Let's write the species we have on the reactant side. We've got H's, we've got Cl's, we've got NA's, and I'm going to write the OH as a unit on the reactant side. Let's do the same thing on the product side. We've got H's, we've got Cl's, we've got NA's, and we've got that OH that we're going to keep together. Let's count on the reactant side. It looks like I have 1 H, 1 Cl, 1 Na, and 1 OH. Now, I've got them in the same order, right, as I listed them in the reactant side. So I kind of have to look through on the product side. How many H's do I have? Right here, there's 1. How many OH's? Right here, there's 1. How many Cl's? There's 1. How many NA's? There's 1. So everything looks like it matches up on the reactant side and on the product side. So this does look balanced. All right. So let's try the next one. As I said, The more of these you do, the better you're going to get at them, and the quicker you're going to start balancing these, being able to balance these. All right, let's take a look. We're trying to find one thing that is not balanced. So right now, I notice that I've got two N's on my product side. I only have one on my reactant side. It's a little bit tricky because we've got NAs in two places, and then we've got N's as well. So we got to distinguish between those two. Regardless, I've got two N's on this side, only one N on the reactant side. So if I put a 2 here, that takes care of my N's. However, it means that my O's now, I'm just going to stay with this same compound, my O's now are out of balance. If I take a look, I've got 2 times 3 here. 2 times 3 is 6, so I've got 6 oxygens on the reactant side. In order to have 6 on the product side, I'm going to need to put a 6 here. I'm going to also take a look at my Na over here, because putting a 6 in front of the Na2O means I have 12. 6 times 2 is 12 NAs on the product side. Now if I take a look at the reactant side, I already have 2 NAs here, but I have 12 on the product side. So 2, I need 10 more over here in order to balance this equation. And once again, just to finish it up, let's put a 1 in front of the N2 to indicate we do have 1 N2. Let's do our check just like we did before. What do we have on the reactant side? We've got NAs in 2 places. We've got N's and we've got O's on the reactant side. On the product side, yeah, I've got NAs, I've got N's, and I've got O's. Let's do a quick count. On the Na, now again, in 2 places we've got NAs. We've got 10 here and 2 more. That's 12 NAs. Still on the reactant side, it looks like I've got 2 times the N. So I've got 2 N's. And 2 times 3 is 6 oxygens. Let's take a look at the product side. In terms of NAs, 6 times 2 is 12. 12 NAs. In terms of oxygens, 6 oxygens. In terms of N's, 2 N's. Again, these numbers match up. 12, 2, and 6. So I know that this equation now is balanced. I've got the same number and type of atoms on the reactant side as I do on the product side. All right, let's take a look at the next one because it's kind of interesting. It highlights one of the interesting elements on the periodic table, sulfur. Whenever sulfur is involved in a chemical reaction, it never ever exists by itself. It always combines with 7 other sulfurs to form S8. So sulfur will never ever exist by itself. All right. If it's in a compound, well, it can have any number of atoms combining with something else. But if it's by itself, it's always going to be S8. And that's something you're going to need to memorize, right? Sulfur is one of those elements on the periodic table that never exists as a single atom. It's always S8 when it's by itself. So let's take a look at this one. Sulfur is obviously the atom that's not balanced. I've got 8 of them on the reactant side, but only 2 on the product side. So if I put a 4 here, that should balance things up for the sulfurs at least. That gives me 8, but it also gives me 4 carbons, so I need to put a 4 here as well. Again, let's do our double check. On our reactant side, we've got carbons and sulfur. Product side, carbons and sulfur as well. Reactant side, 4 carbons, 8 sulfurs. Over here, 4 carbons, 4 times 2 is 8 sulfurs. So there we go. The first couple are done for you. Once again, if I can get you to work on completing this practice sheet, as I said, very important skill, I'll post the answers to it as well.